This is section 1.4, composition of functions. So we're going to talk about putting two functions together in various ways today. So we're going to start with algebraic combinations of functions. So our algebraic combinations are sum, difference, product, and quotient. So to do f plus g of x, you just take f of x plus g of x and simplify. Difference is the same thing except now you're subtracting. Product, same thing, now you're multiplying. And quotient, same thing, but now you're dividing. Notice that g of x cannot equal 0 because remember you can't divide by 0. So let's find all four algebraic combinations for f of x and g of x. So let's start with f plus g. So the sum, so we take f of x, which is x minus 1, and we add g of x, which is x squared minus 1. Now what we're going to do is simplify. So my 1 didn't make it in there. There we go. So simplify. X squared is by itself. That positive x doesn't have anything to go with it. And then the minus 1 means minus 2. So that's our sum of f and g. Let's look at f minus g now. With this one, it's pretty important to use parentheses. So x minus 1 minus x squared minus 1. Okay, remember that minus means like it's a negative 1 and we have to distribute in. So we have x minus 1 minus x squared plus 1, which gives us negative x squared plus x, and then that negative 1 and plus 1 cancel out, so it doesn't matter. And that's it for the difference. Next up, we want to do the product. So f times g of x. So we take x minus 1 times x squared minus 1. Back to algebra 1. Remember the FOIL method, so x times x squared is x cubed. X times negative 1 is negative x. Negative 1 times x squared is negative x squared. Negative 1 times negative 1 is plus 1. And I want to rearrange that so it's in standard form. So minus x squared minus x plus 1. And last but not least, we have f divided by g of x. So we take x minus 1 dividing by x squared minus 1. The only thing I want you to look for here is if you can factor and cancel out. So remember x squared minus 1 factors into x plus 1, x minus 1. Nicely done, we can cancel these out. So we get 1 over x plus 1. So those are our four algebraic combinations. All right. Composition. So I'll refer to it as Fogg and Goff. So we would read this f of g of x. So it kind of looks like Fogg. Notice that O isn't actually an O. It's just a circle. So what we would do is like we talked about, like if you're finding f of smiley face, you would put smiley face wherever x is. Now instead of x, you're going to put in g of x. So whatever g of x is, you're going to put that in place for x. Make sure you work from the inside to the outside. So let's see what that's going to look like. So we're going to find Fogg and Goff for this one. So f of g of x. So f of x is x squared, but now wherever we see x, we're not going to put x squared, we're going to put x plus 2. Okay, because that's what g of x is. Notice that these two things are equivalent from here. So f of x plus 2 is going to be x plus 2 squared. And all I'm going to do, remember squared, it means write it twice and multiply. And I'm going to FOIL it out, so I get x squared plus 2x plus 2x plus 4, which gives me x squared plus 4x plus 4. So that's fog. Let's try Goff. All right, so g of f of x means g of x squared. Remember, if we look, f of x equals x squared, so we're going to take g of x squared. And we know that g is x plus 2. Wherever we see that x, we're going to put x squared now. So we have x squared plus 2. That one we don't have to simplify, but notice that you do not get the same answer. Okay, that's going to usually happen, that you're not going to get the same answer. All right, then we can do it using a table. So using the table, find f of g of 3 and g of f of 3. So first thing we want to do, work inside out. So let's find what, for the first one, let's find what g of 3 is. So I'm going to look in the x column for 3, and then go over to g of x. So g of 3 is 2. So that means we're going to look for f of 2. So go in the x column down to 2, over to f, which gives us 8. So f of g of 3 is 8. All right, now let's try that with the other one. So g of f of 3. So we need to find f of 3 first. Go down the x column to 3, over to f, and I get 3. So I want to find g of 3. So I'm going to go down the x column to 3, go over to g, gives me 2. So the answer is 2. Now we're going to evaluate f of g of 1, but we're going to use a graph. So same thing, we're going to work inside out. So let's go and find, so we need to work inside, so g of 1. So I'm going to go to the g graph, which is graph A. So what x is 1, so I'm going to go from 1 up to where the actual value is, which is right here. So g of 1 is 3, so we need to find f of 3. So let's go on the f graph, which is B. So go over 3 and keep going up or down until we get to that function, and it's right here. We want the y value. So f of 3 is 6. So that means f of g of 1 gives us 6. Fun fact that we can use inverse or composition. Okay, so Fogg and Goff, we can use that to determine if two functions are inverses. So if you find f of g of x and get x, and then you do g of f of x and also get x, that means that those two are inverse functions. Okay, so we want to figure out if these two functions are inverses. So let's find Fogg first. So f of g of x, we're going to take the f function, and wherever we see x, we're going to now put 1 over x minus 2. So 1 over x minus 2 plus 2. Notice that -2 and +2 are going to cancel out. And we get 1 over x, which is the same thing as 1 times x over 1, which gives us x. So, looking good so far. We got f of g of x to be x. Let's go the other way. So to find g of f of x, we're going to find g of 1 over x plus 2. So let's take the g function, so 1 over x plus 2 minus 2. Just a shortcut, whenever you have 1 over a fraction, that means you can just flip the fraction, so we're going to take that and it becomes x plus 2. And then we have that minus 2 on the outside. These are going to cancel out. We're left with x. Since we got x for both of those two functions are inverses. So finding the domain of a composite function on the homework, I'm not so worried about this. You can forget about the domain part. We'll talk about that another time. So just worry about, we're going to worry about the algebraic combinations and